Whoa.
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 All right.
None of that is my calculus.
So we're going to consider this function, and I tell you we're starting at, where are we starting at? -3. So you all have your papers here. So just like last time, from -3 to -3, we know this first one is 0, right? And do this for me. Let's start graphing it. So at -3, let's put the value 0. Because I want to go back through this again. I know it's been a little bit. G is the antiderivative of f. So let's think of this graph as the derivative. Everybody with me on this? Because the antiderivative of a derivative takes me back to the original function. So at g of -3, I have 0. At g of -2, it's the area of this trapezoid, right? So we know that's a negative value. Would everybody agree with that? It's a negative value. And let's see, the area of that trapezoid, you guys are going to have to help me out here. The height is 1, so it's -1/2 times the height. And the sum of the two bases, this base is 1, this base is 3, right? So 1 plus 3, so -1/2 of 4 would be -2. Everybody in agreement on that? Let's go ahead and graph that also at the same time. And then g of -1 would be from here to here. Now see, look at this now. See how this part's negative and this part is positive? Y'all with me on that? But they do cancel each other out. Aren't they the same thing? So what is g of -1 then? No, it's not 0. It's -2. It's -2. We don't change. From g from -3 to -2 is -2. And then if we go from here, that negative plus that positive keeps it -2. Would you all agree with that? So let's get, right here, let's keep it at -2. Okay, to g of 0 then, we're going to take our -2 and we're going to add in this positive area, and that area is 1. So what's g of 0 then? It'd be -1. Good? About that point. G of 1. What is it? No, it's not -1. So up from here to here, I have -1. Then I'm going to add that half triangle. So what's g of 1? -1/2. So at g of 1, we're at -1/2. At g of 2, well, from 1 to 2, I go back negative, don't I? So I go back to, don't I go back to -1?
Yep.
And then what's g of 3? -1/1/2. So -1.5. And I guess I'll plot those two real quick. We're at -1, -1.5. Okay, at g of 4, I go up 1/2 again. So I go back to -1. At g of 5, I go to -1/2. So at g of 4, I'm at -1.5. No, g of 4, I'm at -1, excuse me. At g of 5, I'm at -1/2. Now let's answer that last one. G of -5. So at g of negative 5, look up here. I was here, I'm going this way. That's a negative rectangle and trapezoid, but that answer is all going to become positive. Would you all agree with that? So look at this. What's this area of the rectangle? It's 1 by 3, so that's 3. How about we plot g of negative 4 to be positive 3? Why is it positive again, guys? Because we're going backwards. Plus, look up here, plus then let's go another 1, 2.5. So that becomes at negative, what is that? Or becomes positive 5.5. So what did I say there? Positive 5.5. Okay. Michaela, what's the question here? I'll hit pause on the recording. This is the derivative. See how all this is negative? It's negative up to here. Look, my original function's decreasing to right there, if you will. Right? Maybe. And then it's, isn't it right, starting here positive, so it's increasing, decreasing, increasing. Now I'm not even going to worry about the concavity because there isn't any, because these are all straight. Well, there is a little bit of concavity. If this derivative's decreasing, this is concave down. So it'd be like this. And then since this has got a derivative that's 0, this would be a straight line. Since, look here, look up on the screen, since from here to here I'm increasing, that's concave up. Here it's a straight line again because this derivative is 0. And now I'm decreasing to there, so this is concave down, concave up, and then, whoops, excuse me, that last little part I messed up, concave up, and then concave down. Again, how do I know the concavity? Because if the derivative, which is this f function, is increasing, it's concave up. If the f function, which is the derivative, is decreasing, it's concave down.